Hello everybody, it's Brian and I'm back with another Fusion 360 quick tip. Today we're going to be talking about the shell command. It's an incredibly powerful tool that allows us to take a solid geometry, like this solid rectangle in front of us, and turn it into a hollow object, or an object that just has thin walls. It's a relatively easy tool to use, although you can get into trouble with the thickness of the shell. And how that plays into a geometry that has some constraints to it. So we're going to work through a couple different examples here in relatively quick succession, just to give you a sense of how to use the tool effectively. So the shell tool is in your modify menu. Modify meaning that it has to have an existing geometry in order for you to start to apply some things to it. But it's right here, the shell command. The first thing it asks you for under faces and body is if you want to remove any faces. So I could shell this object and make it hollow inside, but I'm not going to be able to tell that it's hollow inside if I can't see inside of it. So this allows me to essentially say, like, oh yeah, I want to remove this top face, right? You'll see that one is selected there, so that I can see inside my box. Inside thickness, so this is how thick do you want the walls of your box to be. This box is 100 millimeters by 100 millimeters. Let's make these walls 2 millimeters thick, and you'll notice that Fusion starts to create the geometry for you. So now we're looking inside this box. We've removed that top surface, and it's telling you that your wall thickness is 2. Under direction, relatively simple. Inside, outside. So what outside does is it takes your geometry and it puts the shell on the outside of it. So this would be your internal volume, the inside volume of whatever rectangle you have would be this size, and then it's going to make it bigger than the drawing, the geometry that you drew. So this is 100 by 100 by 55 tall. If I make this wall thickness 2 millimeters, it's now 104 by 104 by 52 tall, or sorry, 57 tall, because it's not adding dimension for this top face that we removed, but it is adding dimension for the thickness of this bottom plate. So that's the outside option. The other option is a symmetrical option where you're creating the wall thickness in both directions, and you can actually say, from my geometry I want it to go inside 1 and outside 2, so you don't even have to make it symmetrical, right? In this case, I wanted that to be the outside of my box, so I only want my walls to be projected inward, and we'll give them that dimension of 2, and that is going to go ahead and give me that box geometry. So again, incredibly powerful. I didn't have to draw like individual rectangles and extrude them up to form this box. I just drew the big box and shelled it out to get that geometry, right? And you can see the bottom box is intact. We can also go back to that original geometry here, and we can select 2 faces for that same shell process. So I'm just going to go back to create shell here. Faces that I want to remove, I'm going to click that one, and I'll remove this bottom part here as well. We'll make it 2 millimeter thickness again on the inside. And when I do that, now I just have the outside of that box. So you can effectively remove as many faces as you want. I could remove the top, the bottom, and this side, and then I'm left with a kind of 3-sided room, if you will. Really quick way to make geometry that doesn't involve a complicated sketch. The sketch is literally just a rectangle. So that is shell in kind of its simplest format. Again, I said it's incredibly powerful. We can apply it to some more complicated geometry. So here I've just drawn a quick sphere. With this sphere, it would be impossible to remove a side because it's a sphere. So I did a quick extrusion of a circle up through the sphere to create this little cylinder so that I have something that I can remove here. And so same deal, I'm going to use the shell tool here. Faces or bodies I want to remove. I want to remove this guy. I'm going to stick to the inside here. We'll give it a 2 millimeter wall thickness, and if we click OK, we can zoom in here and you can see the inside is empty. It's sort of letting you see through it, but here's my sphere, right? So the bottom is intact, the top I've removed that, and what I'm showing you here is like the sphere itself is incredibly complicated geometry, right? I mean, there's all these curves, there's a lot of math going on, but Fusion is totally capable of dealing with that issue. The other thing that I'm going to show you really quick is if I don't like this little nub sticking up, again, this is a really quick way of kind of hollowing out this sphere. I can just go into extrude here, I can grab that surface and I can actually cut it down in, and I can get rid of that altogether. And so now I just have a hollow sphere. Very, very quick way of dealing with that situation. So that's the sphere. So sometimes the shell command can just not work, and it can become frustrating because you're not really sure why. It often happens on lofted surfaces, and it's because of the way that the geometry of like this face here is being created. Because it wraps under itself, Fusion can't understand a shell because it has like intersecting faces, and it just fails. So this can be frustrating at times when you have a cool geometry. It's like, oh, I really want to turn this into a vase or something. You know, I can go to my shell command and I can be like, I'm going to remove this top so I can make this a vase. We'll make the inside thickness 2 millimeters so that we have a nice wall thickness on the base. And then Fusion will give us an error. And so it's telling us that, offset of the thickness value, it can't resolve the end of the geometry, and you can try a whole bunch of different variables. I can try to make the wall thickness, 0.2 millimeters instead, and lo and behold, it still doesn't like that option. And I think largely it's because these sides are sort of folded over on top of one another. Even if I move to the outside dimension, Fusion's kind of working hard here. You can see it's actually spinning the mouse on my computer. It cannot resolve this geometry, and so really the only thing I can tell you here is to try to like ease back on the severity of your geometry in order to make these things. Because if you look, there's actually a very narrow window inside of these where these aren't intersecting, and it's because it's spinning, it's rotating, this loft is rotating so much around those surfaces. So I can try to go back to my loft. We'll edit my loft feature, and if I try to go back and just bring these things back around, I'm pretty sure I can resolve this in a geometry that Fusion won't have as much of a difficult time with. It's not as interesting, but we still get that spin. So let's try that. I'm going to try that, and then let's try to shell this guy here. Same deal. We'll do 2 millimeters on the inside here. Yep, and so that worked. So here, you can see if I look in there, these sides are sort of sweeping into one another inside, and so that's the issue. Those sides were running into one another when it was trying to create the shell, and it couldn't resolve that geometry. And so that's the answer to that question, is maybe you've gone a little bit too extreme with your geometry, and that's where shell can start to break down. So that's the shell command in a nutshell. Hopefully that was helpful, and you'll be able to use that for lots of cool, interesting geometries in Fusion 360. Thanks, keep tuning into the tutorials, and we'll get you drawing amazing things in Fusion 360.